Hello friends, welcome back my YouTube channel MS Maths. In this video, we are going to discuss about the concept of Venturi meter. So Venturi meter is a device which is based on the Bernoulli's theorem, and it is basically used for the rate to measure the rate of the flow in the it is based on the principle of the Bernoulli's equation. Okay, so in the Venturi meter there are three parts. That is, first part is the converging part, second is throat, and third is diverging part. Converging part means the fluid enters from here, and throat is basically where the like area is basically the slight or the area is less than this area. This is the area A2, and next is basically the diverging part where the fluid will goes outside. So applying the Bernoulli theorem from here, so we'll apply the Bernoulli theorem. So what is the Bernoulli theorem? It is nothing but 1 by 2. I say the velocity is at the part V1 is q1 vector square plus it will be gh or gz1. Basically z1 and z2 are the height from the reference line. Okay, here we have considered that the z1 is equals to z2. Okay, and plus it is nothing but pressure at part P1 upon the density of the density is equal for the water. Now it is equals to, because using the theorem or the conservation of the energy, so it will be equal to the same second part, or that is q2 square plus it will be gz2 plus P2 upon rho. Now we can write it as P1 upon G into rho plus Q1 square upon 2G. Or okay, yeah, it will be 2G. Yeah, it is 2G plus, but like after dividing by G, we'll get this thing. Okay, and because Z1 and Z2 will be free for this case, so it is P2 into G into rho plus Q2 square, Q2 vector square upon 2 into G plus it will be Z2. Now Z1, Z2 will go cancel. So we can write in this way that P1 minus P2 upon G or rho G, okay, this will be rho into G, is equals to Q2 vector minus Q1 vector upon 2G. So we can write in this way. Here the concept is basically the rho 1 sorry P1 P2 upon rho into G. So basically the what is the pressure? Pressure is nothing but rho GH. This is the pressure P1 minus P2. So it will be like P1 or some P upon rho into G is nothing but H, and here the fluid will enter in this way and it will arise in this tube, and it will arise from this tube, and we will take the reference of these two tubes and get the height. So it will be H. So for this height is S, then it will be equals to H. So P1 minus P2 upon rho G is equals to H. Now by the continuity equation, or by the condition we have q1 vector a1 is equals to q2 a2. The velocity and the area for that particular portion, or the multiplication of the velocity and area is equals for both the end. Now here we want to calculate the value, the value of the velocity. Then we find the value of velocity at second point, that is q2 vector. So we can write in this way. So first it is q1. So q1 vector is nothing but q2 into a2 upon a1. Okay, so we will put this h is equals to, so this is your h and this is your q2 minus q1, then q2 square minus q2 square into a2 upon a1 square upon g into 2 into g. Okay, so it will be 2 into g. Now we can write h is nothing but q2 vector square upon 2g is basically 1 minus a2 square upon a1 square. So basically it will be q2. Now if we will free the q2 vector, then it will be 2gh into a1 square upon a1 square minus a2 square. This is the velocity for this. Then we have q2 vector is nothing but a1 upon a2 square, sorry, a1 square minus a2 square power 1 by 2 into root 2gh. So this is basically the coefficient, okay. This is the coefficient. Discharge is basically like this is the coefficient that is CD, okay. So the actual, well, here will not, square will not come. So the q2 vector is basically the CD, it is the CD coefficient into sum into 2gh. So this is the formula for the Venturi meter, and the actual value, if the discharge coefficient, this is known as the discharge coefficient, okay. So this is basically the discharge, that is A2 into Q2, A2 into Q2. So basically the Q theoretical will be A1 upon A2 upon root of A1 square, means A2 square into 2gh. This is basically the calculated, and this is the theoretical that we will compare using this. The value of this CD will 0.98 and 0.99 for the ideal case, and CD is basically the ratio of the actual upon the Q theoretical. So this is all about the formula, and this is, we will write it as some a1 square minus a2 square root, okay. So this is the formula. So thanks for watching my video. Keep watching MS Maths, and for more videos you can follow the channel MS Maths, subscribe the channel. Thank you, bye bye. So this is all about the Venturi meter. So it's like simple, we have used the simple Bernoulli's equation, and we will put some basic concept and we get the result. So these are the basically the application of the Bernoulli's equation or the Bernoulli's theorem. So thanks for watching my video. Keep watching MS Maths. Thank you. Bye bye.